Okay, last time we did congruent triangles. Today we're doing 6.2, which is on similar triangles. Similar triangles have the corresponding angles are equal. So for example, let's take a look at these two triangles. Let's call this one ABC and this one DEF. If these are similar triangles, then this angle here would be equal to this angle here. This angle here is equal to this angle here, and this angle here is equal to this angle here. They're all the same as each other. The corresponding ones are equal to each other, just like in congruent triangles. So that's not different. What's different? Why are these not congruent? Because they're different sizes. So what's true about similar triangles is the corresponding sides are proportional. In congruent triangles, they're equal, but in similar triangles, they're proportional. Now, congruent triangles are similar triangles. They're a special type of similar triangle, but we're just going to worry about non-congruent ones today. So what do I mean when I say they're proportional? What that means is that the ratio of corresponding sides is exactly the same. So for example, if I took this side, AB, if I measured that side, okay, there's the distance AB, however much that is, and I divided it by DE, you get a certain amount, right? I have no idea what it'd be, maybe something like 2, something, because this one looks twice as big as that one, so it's probably around 2. Now, this would be equal to, if I took BC and divided it by EF, I'd get exactly the same amount. If the first ratio is 2, this would also be 2. And as you would expect, AC divided by DF would also give you the same amount. So this is what I mean when we say they're proportional. All right, so what we're going to do is we're going to solve some similar triangles. You're going to get some information, and you have to solve some of the other information. So in this one, this 30 isn't on your sheet. If you're using the homework sheets I sent you, you might want to fill in the 30. So if these triangles are similar, I'm going to tell you they're similar, okay? You just have to, you wouldn't know just by looking at them, but I'm telling you they're similar. There's some things you could figure out. You could figure out, for example, what is angle E? That's the angle sign, right? Angle E right here. How come you know how much that is? Because if these are similar, all the angles are the same. So angle E has to be equal to its corresponding angle, this one, and how much is that right there? 90 degrees. You should also be able to get angle angle A. I'll put it up above. Angle A, how much is that? Well, angle A corresponds to angle D, so it is 30 degrees. Now here's a tricky one. How much is angle C? Well, it corresponds to F, so you know it's going to be the same as angle F, but we don't know that one either. But what you do know is that in every triangle, the angles add up to how much? 180. So remember, if this is 90 and this is 30, you add the 90 and the 30 together, you get 120. So to get the leftover bit, it must be 180, take away the 120, and that gives you 60 degrees, both for F and also for C. Okay, so we figured out all the angles. Now, in terms of sides, what you need to look for is corresponding sides where you know both of them. So for example, these sides are corresponding, the hypotenuse here and the hypotenuse here, but you don't know the length of either one. That's not going to help you. You know the length of this side, 6, but you don't know the corresponding one there. But here's the one that's going to help you the most. 8 and 24, you know both of those, they're corresponding. That's perfect. So what we're going to do is write those two sides as a ratio. So we have 8 over 24 equals, now we're going to write another pair of sides, corresponding sides. Let's go with this pair here, the 6 and the, I don't know, I'm going to call this D, because you could, this is actually a good name for this because it's across from angle D, so you call it small d. That's one thing you can call this. So now make sure you put it in the right order. If you put D over 6, you just got it wrong. Do you know why? Because we have the small triangle compared to the big triangle, 8 to 24. We have to do it in the same order, small triangle to big triangle, so it should be 6 over D. Boy, how are we going to solve this? We've got two fractions which are equal to each other. It's called a proportion. You know how to do this. It's cross multiplying, right? The way you do this is you multiply these two together and divide by the one that's left over. So you have D equals 6 times 24, and then you're going to divide that by 8. And if you do that, you're going to get 18. Now, I imagine some of you are screaming at the YouTube right now saying, Why would you do this? I can tell just by looking at it, it's 18. You're right. In this case, you probably can. How can some people do this so fast? Because they can see that 8 times 3 equals 24, so it must be 6 times 3 to get this one, and 6 times 3 is 18. That's great. That's wonderful if you can see that. It's just that not every question is going to be as easy as that one, and so that's why I'm also showing it, showing it this longer way here. Okay, so we have this side and this side. We don't have anything for this side and this side. Is it possible to figure them out? It actually is possible to figure them out. You'd have to use the Pythagorean Theorem, right? A squared plus b squared equals c squared. I'm going to leave that today. I don't think we're going to do that. I'm going to don't want to complicate things, and it's not in the homework, so let's just leave that. But you could actually figure out those sides by using the Pythagorean Theorem. Okay, let's move to the second one. The second one, it doesn't tell you any of the angles. You can see it's similar triangles because this angle is equal to this one, this angle is equal to this one, this angle is equal to this one. It doesn't give you any angles, so we can't say any of the angles, but we can get all the sides. Now, again, some people are going to notice that 4 times 7 is equal to 28, so all you have to do for these ones is also multiply by 7. 5 times 7 is 35, 6 times 7 is 42, and we're done. I'm just going to do one. I won't do both of them. I'll do one case, just how I could show you how I would do it a little bit slower than that. So let's say I wanted to know how much this side is right here. I'm going to call it E because it's across from the big E. So the pair that's very useful here, not the 5 because I don't know this one, not the 6 because when I first did this question I didn't know this one either. The pair that's useful is the 4 and the 28. I know both of them. So I'm going to write it as a fraction. 4 over 28. It's a ratio, a fraction, right? And then the one I want to get is E, so I'm going to write this pair. Make sure you write in the right order. We did small to big, so we got to go small to big again, 5 over E, and then you can cross multiply. You're going to go 28 times 5 divided by 4. You end up with E equals 35, just like we said. Okay, a couple more to go. Okay, I got to teach you something here. It's something called opposite interior angles. So opposite interior angles are angles. You see these little arrows right here and here? This means that those two lines are parallel. And when you have parallel lines, if you draw a Z like this, a Z like this, the angles in the armpits of the Z, that's not the real term for it, but I call it that. The angles in the armpits like this and this, those are opposite interior angles and they are equal to each other. So we know that this angle and this angle are equal. Now you can also draw your Z backwards, so I could also draw it like this. And the angles in the armpits would be this one and this one, so those are also equal to each other. Hey, look at this. What do we call that when the two lines cross each other? We talked about it last time. Vertically opposite angles, and they are also equal to each other. So this one is equal to this one. Wow, these must be similar triangles because all the angles, all the corresponding angles are equal to each other. Okay, so let's see what we have to figure out here. I guess we're trying to figure out this side here. I'm going to call it A, little a, and this side here, I'm going to call it little d. Now, what's the pair that's very useful to us? It's this one right here, and the corresponding side to that is this one right here. So we have 6, let's use a different color. 6 over 7.2 equals, let's try to find A first. So 6 we put first on top, we got to put A on top. What side does A correspond to here? It better not be D, because we have A over D, we can't solve this. We can't have two unknowns in here. It must be A over 10.8. Let's convince ourselves that's true. A is between dot and check mark. 10.8 is between dot and check mark. So yeah, definitely we have this right. So now we just have to cross multiply. See, this is the time you definitely need to cross multiply. Well, actually, you could do this. I think the answer is 9. I think I just did that in my head. I think I can do it. But it's probably pretty hard to do for most of you. So what we do is 6 times 10.8. I believe 10.8 is 1.5 times the 7.2. Divided by 7.2. And we get our calculator and we find that it equals 9. Yeah, absolutely. So thanks, calculator. A equals 9. So we can fill that in here. We can take this away and put that A is 9. All right, now we want to find D. Personally, I just use the same ratio again, 6 over 7.2. You could use this new ratio we have, the 9 and the 10.8, but I just stick with the original one usually. 6 over 7.2. Now we want to find the d. Be careful. Don't put d over 8. You have to put 8 over d, right? This triangle came first. So 8 over d. So to get d, you're going to go 7.2 times 8 divided by 6. I think it's 9.6. Yes, indeed, 9.6. Okay, so there's our two answers for that one. All right, last one. Oh, they're getting tricky. You have a triangle within a triangle. Now, you don't have to, but my recommendation when you have the triangle within a triangle is to draw them both again. I'll do the best job I can, which won't be very good. And draw them outside of one another. Don't draw them inside. So what do we call this big triangle? That's ABD. ABD. What do we call the small triangle? That'd be ECD. ECD. What lengths do we know? On the big one, we know this is 12, and that's it. In the small one, we know this one's 8, and this one's 10, and we know that this one's 5. Okay, once you've drawn it like this, it's not bad. It just becomes a simple looking question. So this is why I recommend doing it this way. I guess this side would be B, and this side would be A, and away we go. So what's the pair that's the most useful for us here? This pair right here is very useful. So I'm going to write that 12 over 8, let's do A first, so equals A over 5. A equals, I go 12 times 5 is 60, divided by 8. 60 over 8 is 7.5. And then to get B, again, I go 12 over 8, but this time instead of going A over 5, I'm going to go B over 10. Cross multiply, I get B equals 12 times 10 is 120 divided by 8, and that equals 15. And we're done. Now, notice some questions will ask you for this amount right here. They'll say, how much is this right here? Or they could also ask you, how much is this amount right here? But let's just look at this one up here. We figured out that from D to B, that's this A amount, is 7.5. So we know from here to here is 7.5. Well, if the whole amount is 7.5, how much is this amount right here? Well, look, it's 5 from there to there. How much more do you need to get from there to there? You need another 2.5. So watch out for that. Okay, that's it for similar triangles today. We'll actually continue on with this. Next day, we'll have another lesson with more similar triangles. See you then.